Alright guys, so last video we're going to do two more examples of these 3x3 matrices where we want to find the determinant. And we're going to kind of wrap up what this determinant tells us and why it's important. We're going to get to more applications with the determinant Monday and Tuesday next week, but I think probably the biggest, most important one we're going to touch on today. So let's go ahead and let's think about how we could find the determinant of this matrix A. Okay. Now again, remember our golden rule. Find the row or the column that has the most number of zeros, and let's do our expansion there. Okay. Well, notice this first column, okay, has 2 zeros in it already. So let's use that column for our expansion. Okay. So what would that look like? Well, if we're taking those entries, we've got 0 times the cofactor at 1, 1, plus 0, the cofactor at, we're now in row 2, column 1. Okay. Well, we already know both of those go away. Those are 0. Okay. So all we're left with is 1 times the cofactor at the third row, first column. Okay. And this becomes a really easy calculation, okay, because 1 times this is just a cofactor at 3, 1, okay, which is the minor at 3, 1, negative 1 to the power of 3 plus 1. Okay. Well, negative 1 to the fourth is 1, so that goes away. So all we've got left is the minor at 3, 1, okay, and which is the determinant of this 2x2 matrix, getting rid of first row, third column. So we've just got this little guy here. Okay, and lastly, left diagonal minus right diagonal, that's 2 minus 20 is negative 18. Okay. So that is the determinant of this matrix A. Okay. Now, you could do it and get the same answer by doing, say, the first row or the second row. Okay. But we saved ourselves a lot of time by using that first column because we had to automatically cancel out those 0 terms. Okay. So let's check out the second example now. So here again, let's use either the first column or the third row. We just did a column example, so maybe let's try a row this time. So we can go a little quicker. Hopefully we're getting the hang of this. Okay, we've got 0, cofactor at 3, 1, 1 times the cofactor at 3, 2, 5 times the cofactor at 3, 3. Okay, so we're doing our expansion along this third row here. Okay, well this term goes away, that's 0. The cofactor at 3, 2, okay, well that's, yeah, we're going to start to do this a little quicker now. The minor at 3, 2 should be this determinant here, okay, negative 1 to the 3 plus 2, plus 5 times this minor, let's go ahead and erase a couple lines here. Eliminating third row. Oh, undo. Okay. We're eliminating third row, third column. We've got this minor here. Times, again, negative 1 to the 3 plus 3 now. That's negative 1 to the 6th, so that's just 1. Well, this here is 12 minus 12 times negative 1 to the 5th is negative 1. Okay. 5 times left diagonal is 8, right diagonal is also 8. Okay. Well, who knows what just happened here? Right now this is 0 times negative 1. Plus 5 times 0, which is just 0. So we're going to say the determinant of this matrix B is 0. Okay. So we're going to say that matrices with a 0 determinant are special in one specific way. Okay. Think back to that example we did last week in class when we were looking at inverses. Right? And we said some matrices, square matrices in particular, wouldn't have an inverse. Okay. We said that was going to be an example where we got a 0 row. Okay, so let's think about this matrix B here. if we were to take 2 row 1 and subtract row 2, okay, we can tell right away we're going to get that 0 row, which means row or matrix B, right, will not have an inverse. So in general, okay, and go ahead and make sure you have this written down somewhere. If the determinant of, say, a matrix A equals 0, okay, then it is singular. We talked about last week, what does that mean? That means it does not have an inverse. Okay. So if you ever take the determinant of a matrix, you get 0 as an answer, you know that matrix does not have an inverse. If you get any number besides 0, positive or negative, that matrix is invertible, and we can use our process from last week to find its inverse. Okay? So hopefully that's enough to get you started for today. Go ahead and get started on today's practice. And again, if you have any questions, email me this weekend or I will take questions on Monday. All right, thanks, guys.